Okay. So harness engineering. This is kind of a catch-all term. It's kind of starting to be like context engineering when context engineering was hot and kind of like AI agents. Nobody could define what an AI agent is. Some people are still arguing about it. And I think it's going to be the same thing because it's so new and there's so many different things that are in place and that you can do. And everyone kind of has their own definitions. But just like the AI agent thing, I think when I started to see these agents, it was very clear to me that it was just an LLM in the loop that could use tools. That's all an agent is. And when you think about it that way, it makes a lot more sense. And the nerds love to make this really complex, but it's really not complex at all. That's what an agent is. You give a model, a bash tool, a terminal, and that's you have an AI agent. Anyways, the exact same thing is happening with this harness engineering. Really, what harness engineering is essentially, in my opinion, it's this, right? You want to have a harness on your code base because you need to be able to control it. You need to be able, just like a dog, like, hey, like, don't go attack the neighbor's dog, right? Like, you got to yank him back, like, no, bad, et cetera, et cetera. The exact same thing is applying here, but you're applying it to your code base because what ends up happening if you let it, and I've seen this personally, if you let a code agent just run wild on a code base, it can ruin it in like a week. Right? It can just become a huge slop filled mess. And it's much easier to stop the issues before they happen. One of the biggest issues that we've had, we've had a lot of good results with the agents, especially on, greenfield code bases, but we have a couple of legacy applications that we've been putting off of, even really writing documentation because it was made 10 years ago. Nobody wants to touch the project, obviously. A consultant company made this in 2016, and it's a mess. Nobody ever made any documentation. And that's obviously it's half a million line, right? It's a bunch of Java, it's a bunch of everything. Like, it's just a mess, right? Nobody wants to touch it. And a code agent is going to struggle much more in that versus a smaller code base. But also, the biggest issue that code agents have is they tend to just want to go and they don't want to, there's nothing keeping them in check, so to speak. And you saw this really early on with the models like Opus 3.7, where it was just constantly gaslighting you. And the idea is you build a bunch of infrastructure around your code base to prevent those issues from happening. Does that make sense? So obviously I made this way high, but I threw in all my notes, but I also threw in a bunch of my Git history from Tuna Code. I think it's a good example because that's a code base where, obviously I work full time. I have the consultant business. I'm not gonna like, I'm not gonna be as like granular about every single detail. Whereas with my work, it's like, hey man, like I don't care if I look like an asshole. We're stopping the PR because we very clearly have a naming convention. And if I allow you to merge this, right now, all of a sudden, everyone else going to want their own naming convention. And that's how you lose the war, so to speak, long term, because it just ends up stacking on top of each other. It all starts from a very small, just this one time. Let's just merge this one time. So at work, I'm very, very autistic about what gets merged to me because I'm the one that's going to be on call when it goes down. So Tunica, obviously, it's just a side project. It's just an open source project. Who cares, right? But I think it's a good example because it's a good example of some bad stuff that can happen with the code agents and also how to apply the harness like a ratchet, meaning like it's very easy in a greenfield code base. It's much easier to work within those code bases because there's not enough context for the agent to get overwhelmed versus a huge code base that already has a bunch of stuff going on. It's much more difficult. I think it's a good example of both. So I'll go through it just theoretically and then I'll jump into like an actual example. Um, so the biggest thing is like the harness is essentially a bunch of different layers on top of the code base that keep it in check. The first thing is I have a make file. So the make file, it has an install command. So the make file, it sets up the entire environment. It takes into account, hey, are you on Linux? Are you on Windows, right? It sets up the entire environment for you as a developer, including stuff like, your pre-commit hooks, your version of rough, things of that nature. All that stuff happens simply. And you'd be shocked at how many projects professionally and open source, it's just a pain in the ass to install. Like it's just a huge mess. And that's actually one of the biggest issues that code agents have because if you have a bad install in your environment, you're kind of fucked because if you're on a very old version or a very new version, and the main is on, like a middle version, right? By the time you go to merge, it's going to be a mess. So it's a lot easier if everyone's on the same page and you tell the agent, run, make, install, setup, boom, right? Everyone's on the same page, theoretically. Then we have the pre-commit hooks. The pre-commit hooks are very, very cheap, fast checks. They just tries to keep everything as you were in the loop. It's very, what do I call it? It's very jarring when you have to like wait 5, maybe even 10 minutes for your pre-commit hooks to run. So the pre-commit hooks, one of the issues that I had early on is I wanted to put everything on the pre-commit hooks, run all my tests, run all my actions, run all my everything on the commit side. I mean, I very quickly found that that was just not going to be sustainable because it was taking too long. So pre-commit hooks, that's just basically the linters and maybe a couple of other checks, but nothing too heavy. The shape, so this really means like your dependency direction. One of the issues that you have with code agents, like I mentioned, like it can just go and you will have a huge mess. And all of a sudden, everyone's importing from every single direction. And you just let it kind of become this huge mess. Where you can easily say, hey, we've clearly defined the types, we've clearly defined the architecture. It doesn't matter if you don't enforce it though, right? You have to enforce it at the code level. So, okay, you have your imports, okay, you have your modules, but who's actually enforcing that, right? Who's going to stop a junior from going, hey, we've already outlined the entire auth module, but just as one time, I'm going to pull this in from the DB module to make it work. And that is the beginning of the end because code just can go so fast. So shape, it's about architecture mostly, but it's about enforcing that architecture at the code level with the harness. Lastly, so agents and harness MD. Harness MD is my own thing. Agents MD obviously is the open source thing. But pretty much you want to treat these as almost like a constitution, right? When I run the harness, when I'm updating the harness, when I'm auditing the harness, right? Everything is documented on the document itself. There's a timestamp. Every time we change a certain directory, maybe the source, we're going to update that consistently. And if it's not, hey, hold on, you just touched source, the hook fired, hey, you touch source and you haven't updated the agents MD, you're blocked, right? Because that source directory, and it can be any directory, it's just a rule, but it's very important. And I need to have every single code agent be on the same page with those multiple files, but these two are the most important as like a map / constitution. One of the early issues that I had was I tried to put everything on it, and I think OpenAI wrote about this. It's more of a map and a guide. It's not dumping everything in. And then you can tell, hey, agents MD, actually I can just show you, right? It's a lot easier. So it's just a, hey, this is a repository tuna code CLI, start here, right? Documentation, the harness documentation is here. Here's how you do your Git stuff. Here's the top level layout. Here's the entry points. Here's the structure. Here's the boundaries, right? The shape, types, utils, infrastructure, configuration, tools, core, UI. That's enforced at the code level. Something from, let's say, if we wanted to go in this direction, right? Just for whatever reason, core is going to go into infrastructure. There's nothing theoretically wrong with that. And it might work, it might pass all the tests, but we've already taken the time to clearly architect it. I'm not going to allow it to happen because if I allow it to happen once, it's going to keep happening. And this is enforced at the code level via test, right? So more of this in this architecture boundaries. Documentations. Documentation is something that can get very out of hand if you let it. So you really need to treat your documentation as like a living, breathing part of your code base. You can also add rules. An example, so you have a very important class and you have, I don't know, like say 4 different modules of that class, and somebody adds a new class, but they didn't add any documentation, that's a block, that's a fail. Hey, this class is very important. We have documentation. If it ever changes, let's say length or whatever you want to call it, the amount of functions, whatever, right? I'm just making stuff up. Somebody needs to have a test that says, if this changes, that's fine. We can talk about it. But I don't want people willy-nilly changing my very important class, right? I'm not going to trust a junior to do that himself. So that's going to get blocked on the action side, on the pre-commit hook side. You can decide that. So all this is mapped out clearly here, right? It's a map. It's not dumping everything to the code agent. It's just saying, hey, go here for more information. And this is kind of again, I gave Codex my Git history where you can really start to see it start to take shape. So around 2025, the hygiene of pre-commit hooks, catching small stuff like dead code. And then I started to add on the action side to, okay, one of the issues that I was running into is sometimes people would do pull requests, but they didn't have the correct local environment. They would push up and then, hey, I got this mess that I got to deal with. Okay, let's handle it on the action side. Then I started to add in dependency layers, enforcing that at the code level. And then you start to see more and more documentation, more and more harness stuff arrive down the road. So like I mentioned, make install, let's all be on the same page. Local gates, I'll show an example here of this as well. So yeah, like I mentioned early, it was the harness has multiple different layers. Every layer is solving a very specific problem. Bootstrap, obviously, that's getting set up. Local gates, there's no reason why rough should not be ran every single commit. It's fast. It's written in Rust. It's very, it's going to take you a couple of seconds. Just lint your fucking code. Like it's not that hard. But again, if you don't enforce it at the code level, you're relying on people not being lazy. Not even lazy. People just forget, right? Hey, it's a Friday, 4 p.m. I got to push this up. Who cares? Just push it up, right? But again, you want to stop as much as possible at the code level because people are going to fail you. And all those failures back in the day didn't matter. Not that it didn't matter, but it's just you couldn't do as much damage as you can with a code agent now. So it's very, very important that you enforce at the code level. And then enforcing and protecting your shapes, your architecture, also very, very important. This is an example I found online from, please, Martin Fowler. Very good books, by the way. Martin Fowler, he wrote a bunch of stuff about refactoring and test-driven development. But this is kind of the idea. It becomes somewhat of a loop, and there's different layers in the loop. Defensives. So this is kind of the loop, right? You have almost like it becomes like a flywheel where the agent takes an action, the loop comes in, maybe it's not linted, maybe it's importing from the wrong module, whatever, right? It all becomes now automated. Yes, I'm still reviewing the code, but now I can feel much more confident when I have the agent running to not completely destroy my code base because I have all these different checks. So it's kind of like I did put a little bit of effort into this manually. So it's very, very important, especially if you're working with a lot of juniors like I do, that you make the good, easy path as cheap and fast as possible because an agent, Claude code in the hands of a junior, it literally is that meme of like the monkey with the machine gun. Like they will fuck your shit up faster than like you can even like. It's amazing. It's kind of amazing actually, and it's very, very important that you make the correct path for them easy, accessible, because it's not their fault, right? We've given them like this nuclear fucking device, and they can blow shit up. It's not really their fault if you allow a bunch of slop to allow it to be merged. I mean, that should have never happened in the first place. Again, it didn't matter always, right? All this stuff did matter, and this is not new, but it's just so much more important, so much more key that you have discipline in the harness because of how fast you can go. So I'll show a couple of examples and then I'll wrap it up. Let me just like blow up this thing. Okay. What's this? Model fast high. Okay. So Jesus Christ. Make an example of the modules importing incorrectly to show the harness and make the rough commit hook fire with a bad example. Anyways, so you're seeing it work here, and I'll show an example as soon as it finishes. Okay, so I'll cut it short, just that don't take up a lot of time. But there's an example, right? The harness fired, so the agent made a bad example of rough by doing an undefined name, so rough fails, and then the dependency layer that also failed because I didn't import, or the code agent didn't import in the correct way that I've already architected and thought about. If you let the code agent, like if this was a regular code agent and I just had, for whatever reason, I had asked to do something where I'm importing modules wherever I just want to fix a problem, it will push through these solutions that on the surface level look like they've actually solved the problem and it'll sound very confident and it's working, right? It's passing the test, right? Who cares? But again, it's like death by a million little cuts because you let it happen once and then happens again. And the problems start to stack on top of each other. And then what you end up doing is you end up finding yourself in the loop of like, okay, just this one time that builds a layer of tech debt. Just as one time, let's build a layer of tech debt, right? And then by the time you get to actually like, hey, we have like a life or death, so to speak, situation. I need to really fix this problem. You're gonna have like a really fucking hard time because you have like, again, back in the day, this was still the issue, right? But now, let's say on junior was doing like, I don't know, making a number of 5 pull requests a week. Now they're doing, 15, right? The work has almost tripled. And if you don't catch it here at the commit level, by the time you have a pull request and you're trying to merge, it's almost too late. That's why it's so important to have the harness around your code base. Else you will get fucked. Anyways, that's it. Thank you for coming to my TED Talk.